This is a Febco 765 1-inch diameter pressure vacuum breaker, also called a backflow preventer. I'm going to show you how to drain and blow this out or winterize it. I'm willing to bet you're watching this video because you saw one video, they shot out this pet test port, you saw another, they shot out this one, and you want to know which one should I use. I'll answer that in this video, but I'll tell you straight up, ideally, neither, but if you must, either. And the reason I say that, neither/either, is because ideally you do not want to shoot air through your pressure vacuum breaker. If you look at any document from Febco, Wilkins, or Zurn, they will say don't shoot air through the test ports. Ideally, you want to have a way to isolate the PVB, and then you'll have a port down here where you can shoot the air to clear the water from your sprinkler system before that big deep freeze. Then you come back here, just drain this out, and that's it. You don't actually have to shoot this out with compressed air. However, as you can see on this system, this is a very old system. It has no such hookup, so obviously it's been blown out year after year after year using these test ports, and either of these test ports can work to blow it out. So that's why I say ideally neither, but if you must, either. Check the pinned comment to skip around because I'm going to get into depth in this video just to kind of resolve some of the controversy so you can make your decision on which one to use if you feel like doing this. The difference between these two test ports is that right here sits this check valve, and this test port is on the bottom side of the check valve. This test port is on the top. So this test port is above the check valve, but it is below the air inlet valve assembly, which is made up of the poppet and the bonnet. And so if you have a smaller compressor setup, you're probably better off using this top one. The reason is because you don't have to lift the check valve up. If you have a better compressor setup and you want to more closely simulate the flow of water, then you can use this bottom one. That'll force air in here, push the check valve up, fill up this chamber, seat the air inlet valve, and then the air can head out that way to blow out your sprinkler. So again, check the pinned comment to jump around, but I'm going to show you all of these parts and you can make the decision on which one will be suitable for your setup. But again, ideally, only do it this year. Before next year, put your proper fitting in over here so you can isolate this. And lastly, before we get started, I want to mention that you need to know the rules for your particular address. There's different rules in different jurisdictions regarding certifications on these PVBs. In some places, they have to be certified or tested each year. Other places, they don't. If you're hooked up to a public water supply, it's pretty likely that you have to have this recertified every year. Sometimes that's taken care of automatically by your water company. Other times, you have to pay for it independently. Just be aware of this, especially if you just moved into a new house or a new jurisdiction and you're not familiar with the rules. Make sure you get yourself familiarized with the rules before you open up or in any way change your PVB. You can see on this PVB that there is definitely a leak over here, either at this valve or at the fitting where the fitting connects. This valve was replaced at some point. The current homeowners didn't do it, and they've been here for 25 years, so that was replaced 25 years ago or more. This is the original valve, getting pretty sticky. So between these two parts, this is already looking at close to $60. You can get the whole PVB for about $120. So this whole thing is coming out, getting replaced with a new PVB. It'll have two new valves, two new parts on here, and then of course the internals will be new. And at that time when this comes out, the proper blowout fitting will come in down here. But it still needs to be blown out this year before the cold weather comes in. So we'll go ahead and get started with that. The first thing we will do is drain it. This is a rather helpful document from K-Rain. We'll be using this sort of as a guide, so check the pinned comment for a link to this PDF. So the first thing we're going to do is shut off the main water supply. In this case, it's inside in a small basement. In this house, I can easily find this by just tracing it back through the wall. And this is about 16 feet or so of pipe, so there'll be a little bit of water in it that we'll deal with later. Just follow this all the way back, and there ought to be something like this where we have a valve. So just like those other valves, we're going to turn this perpendicular, so it's in the open position now. We're going to turn it perpendicular to close it, just like that. So now we have a valve closed here. There's still pressurized water up there, the normal water from the house, but there's water in here. But this water is not, once this water is drawn down, no more new water is going to come in. So the next thing we're going to do, either at the controller or if you want to find your valve and just turn the solenoid, or if you have a switch on your solenoids where you can manually override each valve. We're just going to open up a valve for the furthest zone on the sprinkler system. In this one, it is number 8. We might hear a little bit of water move through here, but I doubt it. But let's see. We'll go ahead and go to run. Okay, we just heard that click. That's that valve opening. And the little bit of water that's in there is moving out. So that's just to depressurize it. We just needed it for a second while we can turn this off. Might be wet when you come back up. That's because when we cut the water pressure, well, water supply off here and then put a downstream demand, we depressurize this. No water pressure was available to move the check valve up and refill this chamber with water. And so when we open up that valve downstream, the water drained, atmospheric pressure enters, and that allows this air inlet valve to open. So the poppet falls down, any water above there gets pushed out, and then air comes in. So we depressurized it. We still got a little bit of water in here. This will make more sense, and you see the insides in a second. The check valve sits above this test port. Any water that's below the check valve here, we'll be able to drain that from inside, which is where we'll head next. Next, hopefully you have some type of hose bib or some other type of drain, and you can just open that up and drain this pipe. If you happen to have a fitting like this too, you can remove that and let the water drip out of there. Once this is all the way drained indoors, go ahead and close this all the way. So what we'll do next is we'll turn this valve closed. So this is now closed. So when we start shooting compressed air in here later, the air will stop here. We'll leave this open because we still have to blow out the sprinklers. Over here, we're going to take a regular screwdriver. I'll give a real close look so you can see what I'm talking about. This one is below that check valve, and we've already drained this, so we shouldn't get really anything out of here. That's about right, just a little bit, whatever was sitting right here. This one as well, since we've already depressurized this by opening up that zone, if you open this up when you haven't depressurized it, water will squirt out, but shouldn't really be much that comes out, just whatever's, just that little drop there that's left in this little part here. So at this point, with the water inlet valve closed, with the outlet valve still open, and with the PVB drained, we're ready to go ahead and shoot this out. I'll put up that timestamp if you want to skip ahead to just get on with it. But what I'm actually going to show next is what this looks like inside, the two pieces of the air inlet valve and the pieces of the check valve, so you have an understanding of why Febco Wilkins Zern does not want you shooting out through these test ports, and ideally wants you to isolate this PVB and shoot out from over there. I'll show you what's going on inside here. We just need to remove this nut. This is just to keep this little canopy piece on, which prevents debris and spiders and all from getting in there. Although, be aware, there might be spiders, so be careful when you're lifting it up. Take this off like so. And one thing you can do, if you're going to remove this as I'm showing, make a mark here so you have a reference. You can see it says here, hand tighten. You don't want to use a tool to tighten this. With the system depressurized as it is now, it should be fairly, not easy, but it should be possible to turn this. We're going to turn it counterclockwise, and it is just moving. Okay. It's plastic, so you don't want to break it. Once it gets about a half turn, it's easier to turn. I wanted to mention too, this little tab, you can put a screwdriver here if it's real tough, and turn and kind of tap the screwdriver to loosen that up, but hopefully you'll be able to do it by hand. So I'll just keep removing this. Okay, and this is our bonnet. This is one part of our air inlet valve, and then here we have the poppet. Right, these two pieces are our air inlet valve assembly. We got the poppet and the bonnet, and they go together back like this. And as you can see, this is completely independent of the other valve, which is that check valve, which we'll get to in a minute. It's under that plate in there. So the way this works is, let's pretend my thumb is water pressure. If there's not adequate water pressure down here, the water can flow and when it fills up this chamber, it will flow past here and then through there and out under the canopy. And that's like when you turn your water on in the spring, you'll see that burst of water for a couple seconds. That's the chamber filling up until there's just enough to close that. So when the water pressure is adequate to push on this poppet and push it up against that spring, so it's got to apply some force to overcome that spring, right? But when it does, it will seal that O-ring there, seals up against the bottom of the bonnet, and then the water can't pass through here, and so it'll head out. So this, if you're having troubles seating your with the air compressor, you'll see, if you're, especially like I'll show you in this video, using a small air compressor, sometimes it's not got enough bang for its buck to fill up this chamber quickly enough to seat this. So the way to help that out is just to, you'll see when we do this, but you can just reach your fingers in here like so, okay, and pull up, and then you're going to seal it. And then once it's sealed and the air is coming in, if you have adequate air, you can let go and it'll stay up. So this is a normally functioning air inlet valve. If you're checking this out, you want to check out that O-ring, you want to check this out here. If you're still getting trouble like trying to seat it and it's not working, check this surface, make sure there's not any tears. Anything that would allow a water leak will allow an air leak. This is our check valve assembly here. There's a plate, a spring, and then the check valve itself. So to get this down, we got to push this down against the spring and then turn it, kind of wiggle it just to clear. You can see that there is a guide, and there's a guide, and then this part goes behind. So you push it down, and then once, there we go. So I'm pushing down on the spring still. Once I come up, you'll see that little bit of water that's in there. It'll drain past that check valve, because the valve will move up. There it goes. There goes that little bit of water. So that's the plate there, and then we can just grab this and pull this right out. Okay, now I can show you where these ports go. I'll just stick this tool here. You can see that we're above where the check valve sits, but if we go to this bottom one, we're below the check valve. See that? So we're below the check valve, so that's why I say when you use this bottom one, you gotta push the check valve up, then fill up this chamber, seat the air inlet valve, and then the air goes out. When you use this top one, the spring is gonna already be pushing the check valve down, so you don't have to lift it up. You can just fill up the chamber and then the air heads that way. There's a very little bit of water down there. I'll just put this screwdriver in so you can see it's way down right there. Just hit it, and so it's just a little bit right there. You can see sitting on top of that ball valve. And so at the end of the blowout, you always turn the valves to 45. But I'll just go ahead and do that right here. I'll just turn this valve and you'll watch that water drain out. There it goes. And there you can actually see that position. So this is all the way open on the ball valve. This is all the way closed, and that is, oops, that's about halfway. We'll go ahead and close this now because we'll do the air blowout. So that is the difference physically between using the top port or the bottom port. Again, ideally don't use either. Something else I'll mention that people do in Colorado here is you can buy a cap. It is a proprietary fitting, but you can buy a cap for this. You can take the plastic bits out, keep them inside where they won't go through such cold cycles, and then just reassemble it if that's allowed in your area. It is a proprietary fitting though. There's also what's called a BOB, or a blowout bonnet. That also again is proprietary, but it threads on here, and then there's a 3/4 inch fitting for an air hose. You can always step down if you don't have a 3/4 inch air hose. Again, just know that the rules in your area. Kind of serendipitous that I took that apart because that's all worn out. That's not supposed to look like that. That is wear from this plate over many, many years. And so if you see anything like that, you'll definitely want to replace it. Also, these little legs will break off and things can go wrong with these plastic parts. So I'll just reassemble this for demonstration purposes. Again, if you see anything like that, you actually do want to replace it. Make sure it's clean, and you want to check this seal on the bottom here. Make sure there isn't anything that would obstruct a good seal. Then this fits inside there, so not sideways like this. It actually fits inside that little area. I'll show you a better view. See how it fits in there? I'm gonna put that back in there. Then with this plate here, these these point up as you're putting it in, and those kind of slide like that into this part here, and then this part's just behind it. So you just kind of put it in, and you're gonna have to line it up with the hole, line the hole up there with that. And I gotta be careful because that part being broken, it wants to interfere. So kind of turn it like a skateboard, get it down past there, and then turn it until you've got those guys lined up. So that's not right, because see, it's not correct over there. I gotta get it a little better. It's catching on. There we go. So there and there, and then I'll give you a view of the other side, but same deal here and here. There's a closer look there. That's how you want the plate going back in. Now for the top valve, the air inlet valve, I'm going to be replacing all this, so I'm not going to get too particular, but you want to check your O-ring here if you do have this disassembled. Oops. And each of these valves operates independently. This is just placed down upon here. It doesn't have to be any particular position. Oops. Just so that you can align that center part, get that in there. Oh, and check this O-ring too. You want to check that O-ring, and if it needs to be lubricated, I believe that Febco only recommends Vaseline, but I would probably use like Vaseline or Seal Glide. And then this is lots of turning, but just hand tight. And since we have that mark there, it's starting to tighten up. I'll bring it all the way around back to that mark. Okay, so that's on there. So this is all now back together, and we could put the canopy back on like so and start the blowout procedure. But before we start the blowout procedure, I'm going to keep this off, and you already know why if you watched the preceding part about the disassembly. But if you skipped ahead, the reason we're going to take this canopy off is that it's going to be a lot easier to manually trip this by grabbing that poppet and pulling it into the bonnet like so, especially if you're using a smaller compressor. So let's get started on the blowout. Back to our reference document inside without the wind. Now I want to point out right off the bat, this paragraph here, very first one you see, it says, you will need to rent or buy a compressor capable of providing 20 to 25 cubic feet per minute CFM of air volume, and presumably they mean at 50 psi. This is going to be definitely a rental unless you want to spend a huge amount of money to buy something like that. That's a serious compressor, something that can produce 20 CFM. I don't know that you could find that for under two grand. So I'm presuming that you're watching this video because you want to try to accomplish this task with a consumer grade, let's say 110 volt, 27, 30, 33 gallon compressor. So that's what you will see in this video. There's a bunch of caveats that go along with it, and I'll have some info at the end of the video. I'm not recommending this per se. I'm just showing you how it can be done. The main thing to remember when you're using a compressor of lower CFM, number one thing to remember is if you get everything hooked up, just as you're following along in the video, and you supply your air delivery and your sprinkler heads are not popping up at 50 psi, then that's it. You're going to have to move up to a larger compressor, because you can't increase your pressure. You cannot increase your pressure to try to compensate for air delivery. They're inversely related. So as you increase your pressure, you tank your air delivery. And again, there will be more of that at the end of the video if you're interested. But you'll see an old compressor in the video that's a standard 110 volt. It's, I believe, a 30 gallon, and it supposedly has 8.6 CFM at 40 psi. So that's the reference for what you're going to see in the video. Another piece of info, the sprinkler system that you'll see in this video, it's got a lot of zones, but it doesn't have much demand per zone. The highest demand zone is 4 sprinklers, and together that's less than 15 GPM. It's about 13, a little bit over 13 GPM or gallons per minute. So if you're up on the higher end, if you've got sprinkler zones in the 20 GPM or higher range, you are not going to be able, I don't think anyway, that you're going to be able to evacuate them using the kind of compressor that you see in this video. You're going to have to step up to something a bit more heavy duty. But no matter what compressor you're using, the technique that you'll see next is the same. We're getting ready to add air, so I'm going to shoot at about 50 psi, get that compressor up and fully charged so your tank is full. Regulate down to 50 psi. You want to make sure that you do not add air to the system unless the zone valve is open. That's what all these admonitions are talking about here. We're going to stick to about 1 minute per zone. So how this is going to look is with the compressor regulated at 50 and the tank full on the compressor, we'll go ahead and open up a zone valve using the controller. We know that the zone is open, so then we can go back, hook up the other end of the hose to the compressor, and then we will slowly open up the valve on the air supply. If we have to manually trip the air inlet valve, we'll show you how to do that. Once that valve, the air inlet valve, is closed and the air is moving through the system, have somebody check all your sprinklers and look and see if the sprinklers are popped up, and hopefully you'll see the water getting displaced. If you don't see that, then your CFM is too low. If you see the sprinkler heads pop up and water's coming out, it'll go water and then mist and eventually air. That's a good sign. You might have to make a couple passes because you want to keep it at about 1 minute per zone. After that 1 minute, we're going to come back to the air supply, cut the air supply off, physically disconnect the compressor from that hose so we know that we're not adding any air, then go in and shut the zone valve off. Then it's just rinse and repeat for each of the zones, and then, like I said, with a smaller compressor you're going to have to come back and make at least 2-3 passes. Here is the old compressor that I'll be using to blow these sprinklers out. As you can see, it is a 120 volt. It's portable. It's not fun to drag around, but it's possible. So I can drag this right up to the PVB. I have a 20 amp circuit right nearby. So I can use then this real short hose. This is a 3 foot long, 3/8 inch inside diameter hose. I got a high flow fitting there and a shut-off valve there. Use the shortest, largest inside diameter hose that you can for your setup. Reducing the hose length and increasing the inside diameter optimizes flow rate and reduces pressure losses. So just do whatever you can to optimize. Don't use an extension cord. You'll probably trip the breaker if you do, but even if you don't use an extension cord. If you're in a bind and you have to use either an extension cord or a longer hose, then it's typically better to go with the longer hose, but again, try to optimize the inside diameter on that. If you're really in a bind and you simply must use an extension cord, then you need to use a heavy-duty extension cord, not one of the regular household ones, the 14 gauge. You're going to want at least a 12 gauge. I'll get that tank all charged up when we get over to the PVB, but I want to show you here. I got the outlet regulator dialed down to 50 psi. That's consistent with the document that we're following and consistent with plenty of other sources that you'll see online. Typically what you'll see mentioned is probably 60 psi is the most you want to go for a mixed system. That's meaning like anything with poly in it. You can go up to 80 psi if it's straight PVC, but, and here's the big but, if you're using a smaller compressor like this one, you don't want to go up any higher than you have to because we're not using pressure to displace the water. We're using a column of air flowing at a certain rate, our CFM, our cubic feet per minute. So flow rate, and pressure are inverses, which means that as you ask for more of one, you get less of the other. But we want the most of this, so we have to dial down here. So if you can get this job done at 40 psi, if that's popping up all your sprinkler heads for the full time that we're applying air, that, you know, about a minute each zone, then that's ideal because you'll be optimizing your flow rate, whatever the rating is on your compressor motor. You cannot compensate for inadequate flow by increasing pressure. So if you're using an improperly sized, if your compressor is too small, meaning the motor is too small, if you can't keep up with a certain flow rate, increasing the pressure isn't going to increase the flow rate at all. It's going to decrease the flow rate. So name of the game for the sprinkler blowout is maximum flow rate, not maximum pressure. So let's stick, like in this system, we're going to stick at 50 or below. So just to recap, inlet valve is closed, outlet valve is open. Whichever test cock you're going to use, close the other one. I'm going to go ahead and use this top one. So I'm going to close this, close the lower one. All right, turn it so that's perpendicular, so that's closed. I've got a little Teflon tape here on the end. The other side is not connected. I'll go ahead and put this on here. Doesn't need to be crazy tight, just good enough to prevent an air leak. So this is hooked up. I got that valve closed. Doesn't matter right now anyway because this is not connected. But this next part's very important. do not supply air to the system until you have a zone open, a zone running, a valve open. You don't want to pressurize this system with no outlet. So we're going to head in, use the controller to open up the furthest zone, that's zone 8 again in this case. And then once we know for a fact that that zone is open, then we'll introduce the air into the system. So we're down on here. I got this set to single station. I have it for 15 minutes just so that I know for a fact that it's going to be open in case I get distracted. Hopefully it's not getting so windy that it's interfering with the microphone. But we're ready now to go ahead and introduce the air. We have the zone open. And we've got this open, this closed, this open, this closed. I got that valve closed on here, and I'm ready to go ahead and plug this in to the compressor. Compressor is charged up. It is regulated at 50. And now here's what I mean when I talk about helping the that inlet valve. When I turn this, you'll hear air moving in. All right. Even if I open it up all the way, it might not be enough to seat that. Okay. So the way that we can get around that is by reaching in here. Reach your finger in here and just pull this up and push it, give it a little help, push it up against the spring, and then when I open this up, you'll hear it seat. Here we go. There we go. And now we're blowing out that zone, so let's go have a look. Here's one of the sprinklers in our zone. We're gonna just keep watching all these until we get air out. If we have to make multiple passes, we will. We want to run for about a minute max on each zone. The compressor is trying to keep up. After about 1 minute, you want to cut it off here, turn over here. You can turn the compressor off and then physically disconnect it here. So now that we know we're not adding any air to the system, we can close the zone. I have this physically disconnected here. I've got that valve closed there. Depending on the condition of your system and if you have any leaks, for example, anywhere along here, and depending on how fast your compressor charges back up, this may drop back down. If it does, just pull it back up for your next zone. I'm going to turn the compressor on now to get it charged all the way back up. On this compressor, since it's a smaller one, I found that if I stop it before the tank regulator kicks in and would shut off the motor. If I wait till, like, let's say tank regulator comes in at like 130, if I wait till like 120, 125, so the motor is still running, and then I go ahead and connect and apply air to the zone, I find that it seems to keep up a little bit better. There's less of that initial drawdown, so it's going to draw down, of course, a big amount anyway, but the motor's already running. I'll show you what I mean in case you're dealing with a similar setup. So I'm going to go ahead and turn this on. It's going to get loud. I'll let this tank regulator almost cut out. I'll catch it before it cuts out and then go ahead and connect it. This zone has 4 sprinklers in it. Cut that off there. So from here it's just going to be repeat for every zone, and I'm gonna, because I got the smaller compressor, I'm gonna have to make at least 2 passes, probably 3. So just to show again, I have this disconnected, this valve is closed. I waited for this to go ahead and drop down so I could show you one more time how to do that. I have a zone open. Make sure you have a zone open. Remember, zone open before you apply the air, and then shut off the air before you close the zone. So I'm just gonna put the other end of this into the compressor. Compressor is regulated at the right level and it is in the auto position, so it'll kick on. I'm gonna reach back in here, pull this up against the spring as best I can, and open this up. And my glove got caught in it. Alright, and now we're blowing out our next zone. Here's the next zone. Same deal. So lastly here, you can see that I've just switched. I have this on this bottom test port now, and I've got that closed. I've got that open. That's closed, disconnected. I have a zone open, just connected to the compressor. I'm not going to mess with the poppet, and I'll just go ahead and apply some air and see if show you how it's different when you're shooting into that bottom port. Here we go. See, so sometimes, like I say, it's easier if you haven't got a whole lot of kick to go ahead and shoot with this one. We can still sell it from the bottom though. We're just going to do the same thing. I'm just going to hold this up like that and turn this just as before. There we go. So I finished up the third pass on the last zone and everything is done now. So I'm going to turn this to the off position. Some people like to keep it plugged in and on and just change their run times to 1 minute every zone once a week. They say that that helps to prevent solenoid failure at the valves. I don't have an opinion or knowledge on that one way or the other. All I know is that these homeowners have always turned the system off and unplugged it every winter and left it unplugged till the spring, so that's what we will do. So now I'll get it disconnected as you would expect when we open this up, whether it's you opening this valve because you have this hooked up there, or in this setup, if anytime you're going to turn this and open it up, if the poppet is seated up into the bonnet when you open this up, that's going to allow this to decompress. We'll watch that right now. There we go. So that's fallen all the way back down, and I'm just going to take this off. Like I said, I'm going to be replacing this whole thing. You may decide to leave a fitting on. I tend to think it's probably better not to leave a fitting on, because obviously, again, the goal is to just do this year, and then by next year come back and have your proper fitting over here. But even if you have no intention of ever changing the setup here and no intention of adding the proper blowout valve there, I do tend to think that it would be better to not leave a fitting in, just because it seems like it'd just be one more failure point. So, but do what you see fit. And we're just about done. Before we put the canopy on, we're gonna just exercise the valves, just turn them back and forth a few times like this. This one's pretty hard to move, and then we're gonna leave them all at 45, so that's gonna be right there. Okay, 45-degree angle. See how that's at the 45. Same deal with this valve. This one's also hard to turn. Oh, just turn them back and forth a few times. Exercise them. This is gonna get replaced. Oh, that's hard to turn. And then leave this at a 45, right? 45, 45. Same deal here. I don't think these are necessary to exercise. You can try if you'd like, I suppose. 45. And 45. So 45, 45, 45, and 45. The nut on here doesn't need to be super tight or anything. It just needs to prevent the canopy from turning. And that'll do it. Lastly, if your system has anything like this little cap or this kind of style where it's not a valve that you could leave at a 45 degree position, but any kind of drain that's outside that may be subject to freezing, leave it off so that you can have water drip out of here if necessary. If you don't have any other place to put it, you think you might lose it, just put it on and just barely thread it like so that the water can still pass. Or you can take it, put it in a bag, and zip tie it to the main water valve, the main supply, so that you remember to put this on and don't forget. And then of course in the springtime when you turn that main water supply on, you got water shooting out of here making a mess, and you go, oh no. That's another thing you can do to prevent that. Just put it in a bag, zip tie it to the valve. So that is a wrap on draining and blowing out the sprinkler system through this Febco PVB. Again, this is not the ideal situation. Ideal situation is isolate this and blow out through here. But even if you do that, you still need to drain it. So you can follow the drain procedures on this video nonetheless, even if you got the fitting down there. I'm in Colorado, so we get real late frosts. This won't be turning on for quite a while, but in case you need the instructions on what you would do to turn it on, I'll just show you right here. First thing you would do would be to close this valve. Second thing you would do would be to put this on here. Alright, next thing you would do would be to close this valve. Then you're going to come over here, you're going to close this, and you're going to close that. So you have closed, 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 and closed. Then you'd go into your main water supply and slowly open that valve. That'll push the water through the pipes all the way up to here. The water will stop here. And once you've got the water here, your next step will be to seat this. So to do that, you would turn this open like so, and then the water will push up that valve, that bottom check valve, fill this up. A little bit of water will shoot over the top as it seats that air inlet valve, pushes it up. And then once it stops, once the water stops running over, you would come over here and just slowly open this. Slowly open it, slowly, because this is going to be filling your whole sprinkler system. So you just slowly open that. You would do it even slower than I'm showing, but until that's all the way open. And now you would be ready to run your sprinklers. When you turn the sprinklers on, you just want to do a minute or two each zone just to displace the air. The water's got to now displace the air, right? We used air to displace the water. Now we got to do the other way around. And then once water's coming out pretty well in the zone, a minute or two, cut it off and move to the next zone. That's also the time to make sure that all your sprinklers are working, all your valves are working, and just have a good look at everything. And again, hopefully by then, you have the proper blowout valve over here. Or at least that is the plan with this PVB. I'll go ahead and turn everything back to the 45-degree position now so I don't forget. 45, 45, 45, and 45. Here's now a look at the equipment you've seen used in this video in case it's helpful for you. We'll start first with these fittings. Here's a closer look at where we need to thread in our air fitting. This is, I'm pretty lucky on this one. This is a real common fitting here. This is just a 1/4 inch NPT thread. But the other style that you'll see on these is a flare fitting. So this here is the new PVB that'll be going in later, and that's the fitting that you might see. This is a 1/4 inch male SAE flare standard, which is 45 degrees. So you're going to be looking for a female 1/4 inch SAE flare to thread on here, and then whatever on the other side, if you find one with a quick connect on the other side or whatnot. If you want to use this same setup that you see in the video, with this Harbor Freight shutoff valve here and this Harbor Freight little short hose, then you just need to buy a connection to connect from here to here, and so that connection will be that fitting will be a 1/4 inch, let me see, 1/4 inch female SAE flare by 1/4 inch NPT female. So if you buy that fitting, you can use this same setup that you're seeing in the video. You don't have to have a shutoff valve in your setup, but it sure makes it a lot easier. You only want to supply air to the system with a zone open. So that's the usefulness of this shutoff valve. It just makes it easier not to make that mistake. Yes, you could always use these. You can turn these. But it's easier. It's more intuitive to use the shutoff valve. If you're in a real bind trying to obtain a fitting, a flare fitting, you can always remove this test cock, and that other side, I believe, is a 1/8 inch NPT, so you can get something like this. This you can get at like auto parts stores, because this is just a 1/4 inch by 1/8 inch NPT, and you can remove this, turn this counterclockwise, use some Teflon tape and thread that in, and then this side being that 1/4 inch NPT, that'll go right in. You know, again, use Teflon tape, but I'll show you what I mean. On this older one, this is 1/4 inch NPT here and 1/4 inch NPT there, but if you had one of the newer ones and you needed to remove the test cock in order to use something like this, if it was that 1/8 inch, then you just get on here, turn this counterclockwise, and And then again, if it was the 1/8 inch style here, you'd thread that in, and then you'd have your 1/4 inch here, and that would thread right into any of these. Obviously you're going to want to use Teflon tape, but just as a demo. So that's an option for you if you're having trouble coming up with the solution on a flare fitting. And lastly, I just want to talk a little bit about this air compressor in particular, because I got to explain this value right here. And I just want to mention just some stuff about air compressors in general in case it's helpful for you. The first thing I want to mention, since you're looking right at it, this is a regular 120 15 amp hookup you can see here. And this is a sticker that says 5.5 horsepower. And if you're wondering, how the heck did they manage that? Well, they didn't manage that. If you've heard about the big air compressor class action lawsuit that was settled in '04, this is one of the compressors that would have been in that class. I didn't own it at the time. I got this for a few years. I got this a few years ago, I should say, on Craigslist for $100, and I really like it. If you could find it for $100, do it. But also realize that this is a peak horsepower value here. This is not the rated horsepower. So the main result of the settlement was that the manufacturers that got sued, they agreed to stop listing a peak horsepower value here. They now list a rated horsepower. And so recalling that on 120 at 15 amps, you're limited to about ballpark it at 1440 watts and ballpark 1 horsepower at 750 watts. That's going to keep you under 2 horsepower when you're looking at a 120 hookup. So if you're looking at compressors and you're trying to size up a similar compressor to what you see in this video, if you think something like this would work for your system, and you're wondering, hey, wait, why does the YouTube video show this 5.5 horsepower motor on this 120, but all the ones I'm seeing online, it's the only 5 horsepower motors are on 220. Well, that's because this isn't really a 5.5 horsepower motor. It's something under 2. I don't know what it is, but it's something under 2. So just keep that in mind. If you really do want something that's 5 horsepower, you're going to have to move up to 220. The other thing I want to mention is about the rule of 7.5 and then some big precautions on these values over here. You may have seen this rule of 7.5 looking at some air compressor websites or some of the sprinkler blowout handbooks and stuff like that. And what it's describing is a conversion from gallons to cubic feet. And so since we tend to talk about water in gallons and air in cubic feet, there's about 7.5 gallons in 1 cubic foot. So what the rule of 7.5 is saying is take your highest demand sprinkler zone in gallons per minute, divide that by 7.5 gallons per cubic foot, and that will yield you a cubic foot value that will be your minimum volume flow rate, volumetric flow rate at the discharge of your compressor at your regulated PSI. So you're using that bit of information, that volumetric flow rate, to try to size up a compressor. That said, this is more intended for contractors sizing up big jobs with big compressors. It's not really intended for little jobs with dinky compressors, but we're going to go ahead and run with it because it'll demonstrate how these values can be tricky. So let's use this rule of 7.5 to evaluate a residential sprinkler system that has a maximum highest demand zone of 15 gallons per minute. That's probably pretty typical. So we take 15 gallons per minute, we divide that by 7.5 gallons per cubic foot, and that will yield us 2 cubic feet per minute. We then want to use that information to try to find an air compressor that's capable of discharging down here a minimum of 2 cubic feet per minute at our preferred pressure. So let's say 50 psi. This is where the trouble starts, because when we look at these values, they seem to be saying something like that, but they are not saying anything like that. So let's take these values in particular. So this sticker says air delivery 8.6 S CFM at 40 psi and 6.4 S CFM at 90 psi. If I interpret that to mean, okay, if my compressor is running well and I'm dialed down here to 40 psi, I can expect this compressor to deliver 8.6 cubic feet per minute at my discharge at 40 psi that I can send to my sprinkler system to do the blowout. And that's great because I just did the rule of 7.5 and I need a minimum of 2 CFM at 50 psi. This is going to give me 8.6 CFM at 40 psi. That ought to work. And it sounds like it's describing that, but it's not describing anything like that, unfortunately. These values are not even talking about what's happening at the outlet or the discharge. These are actually talking about the inlet. They're also not talking about a volumetric flow rate. They're talking about a mass flow rate. That S on there is our clue there that this is talking about a mass flow rate. So without getting too deep into this, and like I said, I'll do another video on it because it's pretty interesting. Maybe I'll do some tests in it too, but this is what this is actually describing is the quantity of air that this compressor is sucking in of the outside air around it against a certain back pressure, per minute against a certain back pressure. To translate these values to what's actually happening at the discharge, you have to use some equations. Without getting into the equations here, I'll just tell you when I calc it out for this 8.6 SCFM at 40 psi, what that translates to down here is actual discharge at 40 psi is not 8.6 cubic feet per minute, it's 2.4 cubic feet per minute. So how does that make sense? What is that all about? Well, if you imagine that since this is referring to the inlet, it's referring to an inlet air quantity without getting into the S stuff on there. Some quantity of air is going to fit in some volume depending on the environmental conditions. Let's say that this is an X quantity of air in this volume. Well, when it's just around the compressor up here, it's at zero gauge, gauge pressure. Well, I don't want it at zero gauge pressure. I want it at 40 gauge pressure, right? 40 psi, I should say. Well, if this is the quantity and this is its volume at 0 psi, what is its volume going to be at 40 psi? It's going to be way smaller. So the same thing happens with these values when we change them from inlet or intake to outlet. They get way smaller. So that 8.6 changes to 2.4 volumetric flow rate, 2.4 cubic feet per minute at 40 psi. Again, here it's talking about a mass flow rate. This second one, 6.4 SCFM at 90 psi, we're not worried about 90 psi in the sprinkler blowout, but just to demonstrate how not only this is an inverse relationship, and we know that from before that as we increase, or I should say as we increase our pressure, we really tank our flow rate. So for the sprinkler systems, anyway, we want to stay at that lower pressure anyway. But this, when I calc out this 6.4 SCFM at 90 psi to get the outlet conditions at 90 psi regulated, that goes from 6.4 to under 1. So that's an even bigger change there. If you don't want to do any calculations and you're just looking at this video to kind of size up some compressors, and if you're going to use the rule of 7.5 just to see what you can just sneak by with, what you want to do is take this at 40 psi value, whatever the compressor is that you're looking at, take a quarter of that. And that would be a conservative estimate of what's happening down here. If you're interested in that, that would be more like a sixth, but that's not really, at 90 psi isn't really applicable for the sprinkler blowout. With this, the back of the napkin on this, again, without getting into it too deep, 8.6 SCFM at 40 psi really means 2.4 cubic feet per minute volumetric flow rate at 40 psi regulated at the outlet. So again, take about a quarter and that'll put you a little bit closer. And one more important asterisk that I'll add on to here is if you are operating at elevation like we are here in Colorado, you're taking another haircut on these values. I'll put up a chart, you can reference that. In the Denver Metro, they kind of ballpark it at like 83%. I think it's probably a better idea to just go at 80%, and then you won't be disappointed. But particularly if you're in the mountain states and like let's say your sprinkler system's just a little bit bigger, maybe it's 18 gallons per minute, and you're at 7,000 foot elevation, you may just max out on 120. You may not be able to get the actual CFM when you calculate it out from what this is claiming with your elevation haircut to what's actually happening here, and you may have to move up to 220. And in that case, you really would be looking for like a 5 horsepower motor on there. But it's important to consider if you're at elevation that you're not going to get this performance. So again, you want to reduce this value is the one you're really going to be looking at for the sprinkler blowout. You want to take that value, the at 40 psi value, take a quarter of that to get a conservative estimate of what's happening down here. Then if you're at elevation, you're going to cut that down as well again. So if after all that you're saying yes, 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 but what compressor should I buy to blow out my sprinklers? Well, I don't know. I don't know. What's your highest demand zone? What is your elevation? What is this? What is that? All I can say is go big, go bad. Try to do the best that you can, get the biggest bang for your buck. But that said, I realize that probably most people are watching this video because they're going to stick with a 120 hookup and they want to just try to kind of get by. They're okay with taking the extra time for the multiple passes. You just want to see what can you get by with. So what I can do is I will put up some screenshots of some compressors. I just went through the reviews and I typed in blowout or sprinklers just to kind of get an idea of what people are reporting. Now, I don't know anything about these people. I don't know what the elevation is, what the GPM is on their system. I don't know anything, but I'll put this up here just as a consideration for you, especially if you're working with a smaller system and you just want to kind of get a compressor for this purpose. You will at some point max out on the CFM capable from 120 source, and you will have to move up to a 220, especially again if you're at elevation or if you have a little bit larger system. And if none of that is an option, you can always rent a compressor. If you rent a compressor, you'll get real good performance because it'll probably be it will be some type of industrial or commercial rated compressor. If you've seen your contractor blow your sprinklers out in the past and he pulled up with like a towable compressor, that's probably a rotary screw compressor, and that thing is probably putting out over 100 CFM. And that's why your contractor is able to get in and out of there in 20 minutes with a single pass on each zone, because even though he's still dialing down to the proper pressure, but the flow rate is higher, so more air quantity is moving through your system in a minute than anything this little dinky thing is going to do. So you can always rent a compressor. That's always a great option. And this would do a great job. 90 CFM, that'd do a bang up job. You could do all your zones in no time, and then maybe your neighbor wants to chip in, a few neighbors, get them all done. This is showing this current rate, 25 an hour, but it's a 4-hour minimum. And it's kind of neat the way they have this set up. You can rent the hose, and then they even got this, let me see, can I click on that? Yeah, look at that. That's got that Chicago fitting on there to tap into the hose, and then they've already got it reduced down to a air chuck, so you can use your regular hoses to get onto your system and blow it out. So that's another option. If you're watching this video because a big storm is coming in and you're way down on the list and your contractor is just like, I'm sorry, I'm just not going to be able to make it, maybe you can use this info to solve your problem. There's so much more that could be said about these controversial compressors, but we got to stop somewhere. So if you would like to leave a comment because you've got a great setup and you want to share with people, tell us what kind of compressor you use, the size of the irrigation area, the sprinkler area, any little special features, and share that in the comment section, because it would be great to have a resource that people can refer to for the good and the bad on different solutions for this kind of DIY. So I hope this video was helpful for you on your sprinkler winterization. Thank you for watching and good luck on your blowout.